Hi guys, welcome to another lesson of the Daily Dose of Mathematics. Today we are doing a question that we got from one of the learner who said they requested help from us, and then the learner's name is
It's Menzo.
it's Menzo, ne?
Yeah.
So we're going to be assisting Menzo. Now guys, how to work at the Daily Dose of Mathematics. Menzo gave us his solution. We're going to take Menzo's solution, put it in our senior AI marker. After putting it in a senior AI marker, then we can assist Menzo from there. Let's take the question, let's take the solution, Menzo,
Okay,
and
let
then
us
check what does it say.
okay, yeah. Now let us upload the solution of Menzo to our senior marker.
Let's see with how did Menzo do in his
Menzo.
question. Menzo is in grade 11.
Menzo is in grade 11, and then he's saying he's around Pumalanga at Bonzeni. Is it Bonzeni High School?
Okay, Bonzeni High School. Okay. Let's assist Menzo.
Shout out to Menzo, guys. Menzo's trying his best, trying to solve the maths. Now let's see how our senior marker is gonna critique Menzo.
Yeah, remember guys, we don't have prompts that are going to give learners answers. Here we are in the business of teaching learners how to do mathematics. If you are serious about getting good grades, this is the channel for you. Okay, let's hear what.
Final result, frac, SQRT, 3, 2, total marks, 2/5. Marking breakdown. Based on the CAPS marking guidelines for a typical 5-mark trigonometric evaluation and reduction problem, here is the audit of your work for WhatsApp image the 24th of July 2026 at 5:26.03 p.m. JPEG, step, line of working. Assessment. Mark allocation. Line 1. Initial parameters validated. Lines 2 and 3. Standard reduction processing attempted. Critical notation errors and incorrect angle calculations present. See feedback. 1, M. Line 4. Standard exponential transformation applied. Converting bases. 9, right arrow 3 to the power of 2, 1/4, right arrow 4 caret, -1, 8, right arrow 2 to the power of 3, is correct according to exponent laws. 1, CA, final transformation. Incomplete. Special angles not evaluated to reach the final simplified numeric result. 0, A. Total marks awarded. 2/5. Corrective feedback and CAPS compliance. Your knowledge of exponent laws is solid, but your trigonometric reduction notation has suffered a structural breakdown that will trigger heavy penalties in a high-stakes exam. The logical flaw, lines 2 and 3, you wrote, cos equals 360 caret, circ 300. You cannot separate the ratio, cos, from its angle, nor can you set the word, cos, equal to a number. For the tangent term, you wrote, tan equals 180 caret, circ plus 225 and subsequently derived, tan 405 caret, circ. The reduction formula for quadrant 3 requires expressing the given angle as 180 caret, circ plus theta. You added the given angle to 180 caret, circ instead of decomposing 225 caret, circ into its reference angle components. Formal terminology and notation. Under CAPS guidelines, writing naked ratios, like cos equals or sin smiley face, is mathematically meaningless and instantly loses accuracy marks. A trigonometric function must always operate on an argument, e.g., cos 360 caret, circ 60 caret, circ. Socratic question for reflection. If the given angle in the third quadrant is 225 caret, circ, and the standard CAPS reduction format is 180 caret, circ plus theta, what specific numerical value must the reference angle, theta, take to make the statement 180 caret, circ plus theta equals 225 caret, circ mathematically true? Coach's summary. What you did well. Your cross-pollination of algebra and trigonometry is excellent. When faced with a complex fraction containing exponents, you correctly identified that you needed to find prime bases, 3 and 2, to eventually simplify the expression. That is the correct strategic instinct. Area for improvement. Clean up your reduction bracket notation. Always write the ratio directly followed by the parenthesis containing the reference angle breakdown, such as cos 360 caret, circ, text, reference angle. Never insert an equals sign between the trig ratio and its angle bracket.
Okay, this is what the report that we got. Ne? So now we're going to go through the question step by step, trying to assist Menzo. Ne? Now, what is the question there? It says sine
It's sine theta.
Okay, so we have the sin of theta, no?
Yeah.
Is equal to?
Is equal to a square root of.
Then we have the root, no?
Yeah.
Yeah, and then we have?
A fraction, and then at the numerator we have open bracket 9.
We have
close
open bracket 9. Yeah,
close bracket.
Cos,
to the power of cos of 300.
To the power of cos of what? Of
300.
300. So basically, they were trying to trick the learner to say they are supposed to be doing something about reduction formula. No?
Yes.
So they're supposed to reduce this 300 here so that they can make it to be a special angle. So we're going to park that for now.
Okay.
Okay, what else do we have then?
All over.
All over.
Open bracket.
Open bracket.
A fraction of 1 all over 4.
1 all over 4.
Close bracket.
Close bracket.
To the power of sine of 150.
To the power of sine of 150. Again, special angle again.
Yeah.
To the power of sine of 150. Okay. What else do you have?
Multiply by.
Multiply by.
Open bracket.
Open bracket.
8.
8.
Close bracket.
Close bracket.
To the power of 10.
To the power of 10.
225.
10 of 200 and what then?
25.
Okay. Now, here's what I want you to do first. I want you to concentrate. We're going to start by concentrating on the trig ratios because this thing, it seems as if it's complicated, but it's not. If we just look at the trig ratios alone.
Yeah.
So the first trig ratio that you have cos
of 300.
Of 300. Ne? So we're going to simplify this cos of 300 on its own before we start to work here. So we're going to say, what is the best way to write this cos of 300? We're going to go to our Cartesian plane. Just write Cartesian plane.
Okay, Cartesian plane.
So on our Cartesian plane, remember you have 0.
Yeah.
And then you go to where? 290.
Okay.
And then you go to 180.
Yeah.
You go to 270.
Yeah.
And then you go to 360.
360.
Yeah. So if, according to you, where would you find 300 basically? If I were to ask you, where would you find 300?
We'll find 300 on
first quadrant, second
first quadrant,
third quadrant, fourth quadrant. Where do you expect 300? Like if the angle 300, if I said, remember we're measuring our angles from the positive axis. We start from the first quadrant and then we move anti-clockwise.
Yeah.
And then where would you expect to find 300?
The first quadrant.
The first?
Yeah, the first.
300.
Again, like we have 0.
At 0, 90, and then we have 90.
We have 180.
We have 180.
We have 270.
We have 270, yes.
Then we have 360.
And then we have 360. Where would you expect to find 300? It's a value between 270.
And yeah, it's on the third quadrant.
On the fourth quadrant, it's here. Again, it's a value between 360 and 270.
Yeah.
Yeah, so we expect to find it in the fourth quadrant.
The fourth quadrant.
Yeah.
Okay. So
now we have an option here. This is 300 again.
Yeah.
What is the best way to write 300? There are two ways in which you can write 200, 300, using 360 or using 270. Stay away from 270 most of the time because it's a co-function.
Yeah.
So we're going to say, what should I subtract on 300? I got this 360 here on my Cartesian plane. What should I subtract here such that I can get this 300? Because I'm moving backwards. Backwards, I'm subtracting.
Yeah, okay.
So just put an arrow. Yeah, so you can just say put an arrow here.
Okay.
Yeah, what do you get?
What
should I subtract so that
we subtract 60?
Yeah. So this thing here, instead of writing it as 300, another way to write it, I'm going to tell you, I can write it as the cos.
Okay.
Open bracket 360 minus 60.
Minus.
This is 300.
Yeah.
It's good. I wrote it in a useful way. Why? It has a reducing angle. It also has a special angle.
Yes.
These two things are important because reducing angles, they can disappear basically.
Yeah.
And then this one here of 60 is a special angle.
Okay.
So we are done with that first part.
Yeah.
So we also have another trig ratio. Like I want us to work with the trig ratios aside, then we'll go and put them in the equation so that they don't complicate us.
Okay.
Okay, what is the next one that you have? You have sine.
Sine of 150. Yeah.
Sine of 150. Okay. What do you expect to find 150?
150 on the
first quadrant, second quadrant, third quadrant.
Third quadrant. Third quadrant and on the second quadrant.
No. Where do you expect to find 150? Like if you are measuring 150, remember this is our angle here. We start with 0.
Yeah.
We go to 90.
Okay.
From 90 we go to 180. Where do you expect to find 150?
At the 180 side.
Yeah, we expect to find it just between 180 and 90.
Yeah.
It's a value that is going to be between 180 and 90. Yeah. So I'm going to draw my line here to say, okay, here's 150. You can do it with a different color.
Yeah.
Yeah, just to show this is here you have 150.
Yes.
Okay, what does this mean? It means Uguti, a learner has an option to write 150 in two different ways. They can either move backwards or they can either go forward.
Yeah.
So if we say 90 plus, what should we add such that we can get 150? I will stay away from 90 because it's a co-function. That's my rule. So which one am I going to use then? I'm going to use 180. 180, what should I subtract? Because I'm moving backwards.
Yeah.
It's 180 subtract something so that it can give me 150. What is that?
It's 30.
It's 30. So I'm going to say sine of 150.
Sine of 180 minus 30. Or
It's going to, yeah, sine of 150 can be written as 180
minus
30 degrees.
Yep.
It's fine, that one.
Yes.
Okay. So trig ratio number 1 we're done. Cos, okay?
Yeah.
Trig ratio number 2 we're also done.
Yeah.
Let's go to the next trig ratio. What is the next one?
It's tan of 225.
225. 225 now. Again, where do you find 225? Where do you find 225? First quadrant, second quadrant, 180. Is it bigger than 270? Is it less than 270? What do you think?
180 is less than 270.
No, I mean 225. Where do you
225 is less than 270, but then it's greater than 180.
So we expect to find it on the third quadrant.
Yes.
So I'm going to put it somewhere here. You use a different color just to show them. This is for 10.
Yeah.
Okay. Now you have options again.
Yeah.
You can say 270 minus so that you can get the 225. Right?
Yeah.
Or you can say 180 plus because now we are moving forward.
Yeah.
180 plus what? Because I said, 270 and 90, I'm going to stay away from them. Don't forget.
Yes.
I even changed. So 180, 270, I'm going to use them if I'm forced, like there's no option.
Okay.
So I'm going to say 180 plus what? So that I can get 225. My guess is 45. I don't know, but my guess is 45. So it's going to say 10
of 180 plus 45.
Yeah.
180 plus 45.
Yeah,
yes.
say 180 plus 45.
Yeah.
So this is me writing my trig ratio so that they are useful to me.
Yes.
Now you can attempt to go back to your root.
Yeah.
So you can say, okay, inside your root, what do you have then? I think now you know what a trig ratio is supposed to look like.
Yes.
So you say inside your root.
I have a 9 close bracket.
You have a 9 close bracket. Now, since it's a 9, we can attempt to do that, change it to its base prime because we are dealing with exponents.
Okay.
But let's leave it for now. Let's say it's 9, and then you say this one is going to be written as cos. Okay?
Yeah, cos of 360.
It's 360
minus 60.
Minus 60. No?
Yeah.
All over.
All over.
Open bracket. No?
Yeah.
You have what?
I have 1 all over 4.
1 all over 4.
To the power of sine.
To the sub power of sine.
180.
180.
Minus 30.
Open bracket. Don't forget to say sine. Open bracket.
Yeah.
It's 180 minus
30.
Minus 30. Sure.
Close bracket.
Close bracket. Multiply by. No?
Yeah.
Okay. What do you get from there?
Multiply by open bracket 8.
Multiply by 8.
To the power of 10.
It's 10.
Open bracket.
Open bracket.
180 plus 45.
180 plus 1 plus 45. Okay, now we can go back to our Cartesian plane. Remember, we have a Cartesian plane.
Yes.
We're going to try to reduce these things now one by one.
Yeah.
So we start with the first one. 300 is in the first quadrant.
Yeah.
What will you tell me about cos on the fourth quadrant? Is it positive or negative? Remember, we have all students take coffee. What will you say about cos in the fourth quadrant? Is it positive or negative?
It's positive.
Positive. So it means this thing here is going to be written as, you can just put your root again. After you have sine theta.
Theta
is equal to root. Open bracket.
Yeah.
9. Yeah. And then instead of writing it as cos, open bracket, we're going to write it as the cos
of 60.
Of 60. Yeah. Positive 60. Remember, we could write it as positive or negative. Right?
Yeah.
But in this case, we're going to write it as cos of what? Of 60. Sharp. Next, we go to our denominator.
Yeah.
You have sine.
Yes.
Okay, we are in the second quadrant. 150 is in the second quadrant. Right?
Yeah.
What would you say about sine in the second quadrant? Positive or negative?
Sine in the second quadrant.
Or
student. Or sine is positive.
Positive. So it means we are going to write this thing as the sine of theta.
Yes.
So multiplied by, we have 8. That is to the power.
8 to the power of tan 180 plus.
Yeah, tan. Let's check the third quadrant. What will you say in the third quadrant? Is tan positive or negative?
All student take tan is positive.
It's positive. So we're going to have tan of 45. No?
Yes.
Now, guys, if you have a casual calculator has special angles. It's going to allow you to use your calculator without using your calculator. Yeah, it's a trick here. Now, that's the trick that we're going to use next. So instead of using the special angles, you can use the special angles diagrams if you feel it's necessary, but it's not necessary. We have cos. Okay?
Yeah.
We're going to press cos 6 in our calculator. It's not going to give us decimals, you'll see. Okay?
Yeah.
It's giving us a special angle. So if you say cos of 60 is going to give you 1/2. If I'm not
Cos of 60, yeah, cos of 60 is 1/2.
So you have, okay, let's start by saying sine theta.
Sine of
Theta
theta
is equal to
a root.
Yeah, is the root. Then you have open bracket. Right?
Yeah.
You have 9.
9.
Close bracket.
Close bracket to the power 1/2.
Yeah, to the power 1/2. Now it starts to look a little bit better. Can you see it?
Yeah.
Yeah, because 1/2, if we change this 9 to its base prime, we're going to have 3 to the power of 2.
Yeah.
So it's starting to look a little bit better. All over
1. Okay, we are gonna press sine of.
Yeah, sine of 30 is also going to give us 1/2.
Is equal to 1/2.
Yeah, so you have
1/4.
1/4.
Close bracket.
Close bracket.
To the power of 1/2.
Okay, sharp.
Multiplied by
8 to the power of 1.
8 to the power of 1. Okay.
Yeah, if you say tan of 45, just check it, but it's going to give us 1.
Tan of 45. Tan 45 is 1.
Yeah, it's 1. Yeah. So, okay. Much better now.
Yeah, much better.
Okay. So we continue. The sine of theta
is
equal to root.
Yes.
Now, if you, okay, we can say this thing here, we're going to have 3 to the power of 2 instead of writing it as 9. We could have done it so that we just simplify our steps. So we have 3 to the power of 2.
Okay.
3 to the power of 2, yeah, multiplied by 1/2.
Yeah.
And then you can see which 2 multiplied by 1/2 is going to give us 1. Okay, but we'll come back to that on the next step. We made our step unnecessary.
It would be like 9 all of. Why don't we just do it at the same time all at once?
They will give us a mark for changing everything to the prime base.
Okay.
Yeah, so we should just be careful of that. So we could have just changed everything to a prime base. As you heard, they were giving Menzo for changing 9 to its prime base. So there's a mark for that.
Okay.
So just to avoid making unnecessary mistakes. Okay, let's say we have
9/2.
Yeah, we have 9 to the power of 2.
9 to the power of 2.
Multiplied by 1/2.
9 to the power of 2 multiplied by 1/2.
All over.
All over.
Yeah, this one here. If we want to write 1/4 in this prime base, it's going to be written as 2 to the power minus 2.
2 to the power minus 2.
Yeah, what happened is that we took the 4 upwards, and then because it's exponent, its exponent became -1.
Okay.
Yeah, and then we say multiply by the 1/2 that is still outside.
1/2. Okay.
Yeah, multiply by
8.
8. Well, no, we don't write it as 8. We write it as 2 to the power of 3.
2 to the power of 3.
Yeah, to the power of 1. Yeah, from here onwards, you can simply say root and then check what is going to be the answer. Put it in your
Wait, before you go forward, it is 3 to the power 2, not 9. I wrote 9. It's 3.
You wrote what?
9. I wrote 9 there at the top there.
It's 3 to the power of 2.
3 to the power 2, yeah.
Yeah, exponent 2.
Yeah.
Yes. Multiplied by 1/2.
Multiplied by 1/2.
Yeah, which is an exponent.
Yes.
So you have a power, is raising a power to the first power.
Yeah.
So those two are going to actually divide each other, basically.
Okay. So
Fine.
you have sine, you have sine of theta is equal to. Now let's solve it.
Yeah.
Those ones gonna subtract each other, and we're gonna remain with 3.
Yeah, so we remain. So we have root 3 on top of it.
Yeah.
And then below him, again, you still have more or less the same thing, slightly different, but you're going to have
2 to the power minus 1.
2 to the power minus 1, which is half.
Yeah.
Multiplied by
2 to the power 3.
2 to the power 3. And then here, you can try to simplify this because the bases are the same.
Yeah.
If bases are the same and then you're multiplying, you simply add the exponent.
Yeah.
It means we add the denominator. Basically, we're supposed to be left with 4.
Okay. Then that means we're gonna have sine of theta, which is equal to the root of 3 all over 4.
Yes.
All over 4.
That's still fine.
Yeah, still fine.
Okay, so we have in the numerator we have what 3.
Yeah, we have 3.
In the denominator, you say we have 4.
Yeah, we have 4.
Because we said 2 to the power minus 1 multiplied by 2 to the power of 3, and then it gave us 2 to the power of 2, which is 4 now.
Yeah.
The denominator part okay, now we can start to do the general solution, because that's what they were requesting basically. They wanted us to get the general solution. Okay?
Yeah.
So basically here they're asking us where is sine going to be. Okay, let's say we have a root, it's root 3 all over 4.
Yeah.
Oh, it's 1 root now.
Yes, 1 root.
Yeah, we can write it. I'm thinking we can write it as root 3 all over 2.
Okay.
We can write it as root 3 all over 2. And then, they said without use of a calculator.
Yeah.
Oh, okay. Yeah, let's keep that in mind. They said without the use of a calculator. Yeah, root 3 all over 2 is a special angle.
Okay.
Yeah. So now you want to know which trig ratio is going to give you this thing here. This
root 3 all over 4.
Yeah, which angle is that one? It's root 3. So what we are supposed to say, okay, it's theta is going to be equal to the sine arc of
root 3.
Root 3 all over 4.
All over 4.
And basically it's root 3 all over 2.
Yeah.
That's what we actually have. Okay. So which angle is this one here? That's what we're interested in. And then if you check here, maybe we can try to do this. Say sine arc.
In your calculator?
Yeah, in your calculator, say sine arc.
Remember, where do you get the sine arc? You have to say sine, then it's going to give you a sine arc, then you do the root.
Yeah.
Or let me just say, let me not make a mistake blanket of root of 3 all over 4. And then let's close the bracket first.
Yeah.
Close it.
Remember, casual calculator, guys, is allowing us to use a calculator without using a calculator. If we're not using a casual calculator, we're going to use the diagram of the special angles. But if you're using a casual calculator, you can cheat the math somewhere there. So what do you get there?
We get 60.
Yeah, we get 60. Yeah, because root 3 all over 2 is one of the special angles.
Yes.
So we're going to tell them which we have the sine of theta, which is equal to what? To 60.
No, not the sine of theta.
Huh?
Oh, yeah.
No. Theta is equal to what? To 60. Sorry about that. This is our left angle.
Yeah.
So from our left angle, remember, we're dealing with something which is positive.
Yeah.
Now, since we're looking for the general solution, now we're going to the general solution part.
Okay.
On the general solution part, we're dealing with sine, and then we want where sine is positive.
Yeah.
Now, where do we expect sine to be positive?
At the first quadrant.
So we're going to start by saying first quadrant.
Okay.
For the first quadrant, we're going to have theta.
Theta is equal
which is going to be equal to, we accept the left angle exactly the way it is if we're dealing with the first angle.
First quadrant.
Yeah. And then we say which is going to be 60 degrees plus, and then we say k multiplied by 360.
K multiplied by 360.
Yeah, this is it's going to be for sine and cos. Remember, cos and sine, we use k multiplied by 360.
Yeah.
So this is the first general solution. Yeah? Now we go to the second quadrant now. On the second quadrant, we're going to have theta, which is going to be given as 180 degrees minus the right angle. What is our right angle?
Second quadrant. Isn't second quadrant 90?
Yeah?
Second quadrant isn't it 90?
No, it's 180 minus. We don't use 90 and 270. 90 and 270, they are co-functions. Right?
Oh, 180.
Yeah, so we're going to say 180 minus the right angle.
Minus 60.
What is the right angle?
It's 60.
It's 60. Then we say plus k multiplied by 360. And then we'll tell them which theta is going to be equal to 120 plus k multiplied by what? By 360.
Yes.
Where k, don't forget this, it's very important. Where k is an element of all integers. So you just write that z.
K is an element of all integers.
Okay. So this is it's worth the 7 marks, it was supposed to be 7 marks because you had to do reductions after reductions. You had to do exponents after exponents. You had to remember what is the opposite of the special angle here. So there were so many things that we needed to do. Okay, do you propose we put this in our senior marker? Is it going to be possible?
It won't be possible. But then, shout out to Menzo. As long as you put it your senior marker to your question to the senior mark, it's the best.
Okay, it's fine. We hope we didn't miss any notations there. And then we got, this is what we got, Menzo, for your question.